Now, what we have here at this point might seem like a reasonable thing to do. We are ensuring that the result of our selectors is also immutable, and therefore we are guarding ourselves against errors in angular change detection, which could lead to missed synchronizations between the model and the view, resulting in a program that is hard to reason about and troubleshoot. Now, what is the problem with this approach of calling deep freeze on the output of selectors? The problem with this is that even though we are freezing the output of the selector and we are effectively guarding ourselves against mutations in this output that could lead to bugs that are hard to troubleshoot, we are on the other hand effectively not leveraging the OnPush change detection that we have applied in multiple places of our program. And why is that the case? The reason is that OnPush change detection detects if the view should be regenerated by looking at the inputs of the component and comparing them, comparing the current reference to threads with the previous reference to the input that it had. So we are comparing the current value of the thread summary array and we are seeing, is this the same thread summary array that we rendered last time? And the comparison is being done by object equality. So the problem here is that because in our reducers we are systematically making copies of the state to produce the new state either by using object assign or clone deep, we are generating each time complete new objects. So we are always discarding the previous object, the previous state object, and all its nested objects and arrays. And we are creating a deep cloned copy of that state and then modifying it. That state is coming out as being immutable, but it's a completely new JavaScript object tree. So going back to our thread list component, the thread summary array that we receive each time will always be different than the one that we received from last time, even if the contents of the array is exactly the same. Because it's a different array, change detection will mark this component as dirty and the component will be re-rendered. This means that in order to be able to leverage OnPush change detection appropriately, we really need to make sure that the models that we are passing to the view only change, meaning we only send a new thread summary view model if one of the threads changes inside the thread summary view model, or if we add a new thread to the frame summary view model array. In order to be able to leverage the change detection mechanism, we need to make sure that we only change the thread summary array that is sent to the thread list component if there were some changes inside the thread summary objects, or if a new thread summary object was added or deleted. Other than that, if nothing changed, we should not send to thread list component a new thread summary view model array with exactly the same data, because as that is not the same object that was rendered last time, even though it contains the same data, because it's not the exact same array from an object equality point of view, then the component will be re-rendered. So effectively, although the application at this point would still work, we are effectively not leveraging the OnPush change detection strategy. We have all our components being re-rendered all the time, just like before. So now that we understand the problem, how do we avoid it? How do we prevent unnecessary re-renders on our application? And how do we leverage the OnPush change detection effectively? That's what we're going to find out in the next lesson.